Welcome back. In this video, I'll be working on special function part 4, which is problems on um, special function. Now, once again, this is further solutions, further solutions, further function. Now, further solutions academy. Encourage us more. Help us to share and also subscribe to our channel. In this video, we have over 100 videos, and there are more of mathematics, physics, and chemistry. Anyone that you have problem with, drop your comments, and anyone that has parts, start from part 1 and get it well. Thank you. This is a part 4 of special function. Now, I have 2 problems to show, so that by the end of these 2 problems, you should be able to understand what about the first one is this, and the second one is this. I won't do beyond these 2. Now, the first one, I want to show that this and equals to this. And the second one, I want to evaluate this. This is evaluate. Now, why this one is show, I want to show. Now, show that this is equals to that. Now, let us start. Now, the first one, I'm having a problem this way. I want to show this problem. That is equals to what? Is equals to that. How do I start? Solution. It's very simple. Once you understand part 1, part 2, part 3, you will get it right. Now, I can say that what? Let. Now, what I'll just do is that this is the problem for me. Okay, I'm coming from here, from this side to this side. Now, I will just say that what? Let x raised to power 3 equals to what? 8t. It's the same thing over, everything can also be equals to what? 1/3. The same thing, which is the same thing as this. I think by now you understand what I'm trying to do. Now, it means I can say that that is equals to that. Now, since I have that, and my x can be equals to 2 of what? T raised to power 1/3. That is what I mean. It means cube root of 8 is 2, and this is the cube root of t. Now, I want to generate my bound, which is very, very important. When x tends to 0, now my t will also be equals to what? 0, tends to 0. It means when this one is equals to 0, my t will be equals to what? 0. Now, when my x tends to what? 2, what happened to my t? When my t equals to 2, it means my t will be tend to what? To 1. By so doing this, I've generated my bound. Now, since I've generated my bound, I can now move on. At this point, I can say that what? The x will be equals to, my x will be equals to 2/3 dt, 2/3 dt. I mean, yes, 2/3 d, 2/3, I'm trying to t raised to power minus 2/3 dt. Now, that is all about that. Since I have all what I need, I can now move on by having, move on by having integral run from 0 to 2. This is, I'm working with respect of what? Of my function now, which is from here. We have 8 bracket of minus x raised to power 3 bracket of 1/3 now of the x can now be equals to integral run from 0 to 1. Because of what? What am I using there? I'm using the bound below and also below. When the bound is what? Is 0. T is equals to 0. When my band is above, which is 2, it also is equals to 1. That is what is there. Now, I will now it be equals to, I have then I will have my x, which is 2t raised to power 1 all over 3. It means I put the value of x, which is this, is equals to this. Now, I will move on by having bracket of 8 and minus 8t. Okay, which is my t raised to power 3. I mean, x raised to power 3 equals to what? 80. Now, I will move on by having equals to 1 all over 3. Now, since I have this, multiply by 2 all over 3 and my t raised to power minus 2 all over 3 and dt. Now, successfully, I think I've got what I want to got. Now, I can now move on by having draw down the numbers, which is I'm now working on this part. Now I have okay, that is all about that. This 2 times 2, it will be 4 and 3. Integral of run from 0 to 1 and my t, this t and t, they are like times. When you marry the two together, it will be LCM, it will be minus 1 all over 3. And what again we want us to do, I can make it 2 bracket of 8 bracket of 1 minus t bracket of 1 all over 3. No, this cannot be like this. I can open the bracket, close 1 all over 3 and dt. Now, since I have this, I can now move on by having cube root of 3. When I have 8 raised to power 1 over 3, it will be what? It will be 2. Now, since I have that, I can now move on by having a problem. My problem is half solved now. I can say that what? This and this and this. 2 will remain here. 2 times 4, it will be 8 all over what? 3. These 2, when you have 8 raised to power 1 over 3, it will be equals to 2. 2 times what is there to be 8. Now, I will have integral run from 0 to 1 and also t raised to power minus 1 over 3 and bracket of 1 minus t bracket of what? 1 over 3 dt. Now, I think at this point is now I'm now on what? On a plane surface. Since I have this, this can be implied as, it can as well write as what? 8 all over 3, 8 all over 3 beta function of, now this is a t, this is a t. I think it's a beta function already. I can now say that what is my power? Now, before we move on here, let me show some things there that you can really understand at a point so that you won't get lost. I want you to know that for my beta function, my beta of m comma n can always be equals to it always equals to integral run from 0 to 1, integral run from 0 to 1, and I can say that what x, okay, let me use t raised to power m, t raised to power m minus t raised to power m, okay, m minus 1 and bracket of 1 minus x bracket of n minus 1 dt. In our previous video, I was using x, but that was not me. Now, what if I should compare with this, the power of the variable? It means my m minus 1 equals to minus 1 over 3, and my n minus 1 equals to n minus 1 equals to 1 over 3. When I have my like times, minus 1 over 3 plus 1, 1 over 3 minus plus 1. Now, it means my m, it will be 3, that will be 2 over 3, and my n, it will be equals to 2, 3, 4. That will be 4 all over 3. 4 all over 3. 4 all over 3. Yes, the LCM is 3. Yes. Now 4 all over 3. What am I trying to do there? Just to, this thing is very important. I'm just comparing the degree of what I need. Now, since I have that, it means I can now move on to my beta function. Now, my beta function of this and this, it means I'll be having my beta function will now be equals to 8 all over 3 beta of what is, we have up n. What is my n? I have 2 all over 3, 2 all over 3, and 4 all over 3. Come close. Now, since I have that, I can as well write this as a gamma function, which it will be equals to, which I've shown that relationship in our previous video, which is part 3, that my gamma of my gamma of m of gamma of n divided by gamma of m plus n can be equals to beta of m and of n. Since is that, I can now say that what? 8, this will now be equals to 8 all over 3 gamma of 2 all over 3 gamma of 4 all over 3 divided by gamma of that is 2. I find the LCM. It means m plus n. This plus this is going to be 2. Now, since I have that, I can now say that what? It will now be what? What is my gamma of 2? My gamma of 2, it always 2 factorial. I mean, yes, 2 factorial. Gamma of 3, 3 factorial. Now, it means, yes, gamma of 2. Okay. Gamma of 2 is it gamma of 2? Yes. Now, it means I'll be having gamma of 2 is 3 factorial. 3 factorial. 3 factorial. No. Okay. Gamma of 2, it will be, okay, gamma of 2 is 3. Sorry. Gamma of 2 is 3. Since I know that gamma of 2 is 3, it means I'll be having 8 all over 9. It means 9. This is 8 all over 9. It will be gamma of 2 all over 3, gamma of 4 all over 3. Now, since I have that, I can now move on by having my problem to be now be solved by having a function this way that it will be equals to now I have 8 all over 9. My gamma of 3, it will be gamma of gamma of this, it will be okay, I will now have a gamma of this. This is equals to this, which my gamma of this to be all divided by sine 1 all over 3 of this. Yes. Now, I think before we get there, you should know that this it will be equals to 8 all over 9, and it will now be 8 all over 9. I have gamma of 2 all over 3, and this one will now be what? 1 all over 3, and gamma of 1 all over 3. Since I have that, which I will give me that, and it will now be equals to, this one will be that will be 360, 180 divided by 3, that will be 45. Sine 45, that will be root 3. Now, I will be having root 3, and okay, it will now be equals to, this will give me 8. 8 times 2, that will be 16 divided by 9 all over root of what? All over root of pi, that is my final answer, which it has been proved. Now, number 2. Okay, the logic behind it, I think here you should understand that I can use a function of what I've showed in our previous video, that my function can be 8 all over 9 over gamma of 2 all over 3 and gamma of 1 minus 2 all over 3. That is what I'm using here, which it will give us that. Now, since I have that, let me quickly move on to the second one. The second question states that okay, I have this type of function. Now, I have this type of function to work on. It's run from 0 to a and y raised to power 4 and root of a squared minus dy. There is something I just said, let y squared equals to what? A raised to power t, at, and if I should differentiate 2y dy, it will be equals to a squared dt. And since I have that, I want to generate my bound. My bound will just be what? When t is equals to 0, the lower bound, y equals to 0. When y equals to a, upper bound, it means my t equals to 1. Yes, when I put this here, equals to 1, it means a squared will cancel a squared. That will be 1. Now, so I can now move on by having integral run from 0 to 1. What is my a? My y raised to power 4. I think I will be having a squared a squared t bracket of 1 all over 2 bracket of 4. This, it means y, it can be equals to a squared t or bracket of 1 over 2. That's what I'm trying to do there. Now, I will move on by having t of a squared minus what? What is my t? My y squared is equals to this. A squared t and what? What is my, I will now say that what? My dy. Dy will now be what? My dy will be equals to, I'll be having a squared, I think from here dy can be equals to a squared dt divided by 2y. And my y is already given. What is my y? My y is already on this side. It means I will say that what? At dt divided by 2. What is my y? My y is what? My y is equals to at bracket of 1 all over 2 at the up. Now, since I have this, by so doing this, I will do my little things. The one of now, I think this one and this one are very good friends. This one can be 2, this one can be that. With the help of that, I can say that what? If I should factor out all a's, I think this is a level of mathematics that we have a squared all over 2, and we have 0 to 1, and we have a squared t of bracket of 3 all over 2, and I have a bracket of root of 1 minus t and what? dt. Since I have that, what can I do? This is another problem on its own that can also lead to problem. Now, 2 will cancel that t, and I will be having a raised to power 2, a raised to power 3 divided by 2, and divided by 2. This a will also come out. We have another a, which is into bracket of 0 to 1. What remains? I have t raised to power 2 all over 3, and what is my t here? It will be bracket of 1 minus t bracket of 1 all over 2 is a root form. Now, since I have this, what can I do? I can say that what? These are what? A, which is a raised to power 6 divided by 2, integral run from 0 to infinity, and also t raised to power 3 all over 2, 1 minus t, all bracket of what? dt. Now, since I have this, I think, now I can now move on by having this, which I can now move on by having this it means I can compare the coefficient that my m minus 1 equals to 3 all over 2. My n minus, this is 1 over 2, sorry, 1 over 2. My n minus 1 equals to 1 all over 2, which I have 2, I have 6. Okay, it will now be plus 1, which is 2, 5. M equals to 5 all over 2, and my n equals to 3 all over 2. Now, since I have that, yes, since I have that, okay, I can now move on to okay, I can now see that what, therefore, my beta, okay, my beta and my, I will now move on to my beta. Now, it means I'll be running towards the function this way, a raised to power 6 all over 2. It will now be beta of 5 all over 2, 3 all over 2, comma. Now, I will now run this back to what? To gamma function. It means my gamma function will now be equals to a raised to power 6 all over what? All over 2. A raised to power 6 all over 2. Now, since I have that, it will now be what? Gamma of 5 all over 2, gamma of 3 all over 2, all divided by gamma of 5 all over 2 plus 3 all over 2, all close, all close. Now, since I have that, I can now move on by having, which is also can be equals to a raised to power 6 divided by 2. Since my a equals to power 6 all over 2, I can now move on by having 3 all over 2 dot 1 all over 2. Yes. Gamma of 1 all over 2, gamma of 1, gamma of 1 over 2, gamma of okay, gamma of 1 over 2. Okay, this also will be 1 all over 2 will come up 1 over 2, gamma of 1 all over 2 divided by, all will be divided by gamma of 4. Now, gamma of 4. Now, since I have this, I'll be having 2, 2, and 8. It means I have a raised to power 6 all over 2. Everything will be what? This one will now be 3 divided by 8, and 3 divided by 8, and I'll be having root of pi, because this is root of pi, everything divided by, what is my gamma of 4? My gamma of 4 is 3 factorial. We have 3 factorial. Now, since I have 3 factorial, I can now say that what which I'll be having which I'll be having a raised to power 6. Okay, I will be having a raised to power 6 all over 2 dot of 3 all over 8 of pi divided by, what is my 3 factorial? My 3 factorial is 3 factorial. This is 3 times 2, 6 times 1, that will be 6. Now, which is going to be what? 6. Now, I can now move on. 6 here, 3 here 1, 3 here 2, which I will move on by having 2, 2, 2, which I have a raised to power. Now, it will now be what? My answer will now be pi a raised to power 6 divided by 2 times 8. That will be 16. 16 times 2, that will be 32. That is my final answer. That is my final answer. Now, that is final answer on this. Please try as many as you can. Try this question. If you have any problem, drop your comment. It will surely be attended to. Just to prove integral run from 0 to 1, we have ln 1 all over x plus bracket of n minus 1 the x equals to lambda n. Just prove that. Once again, further solutions academy. Encourage us more. Help us to share and also subscribe to our channel. Thanks for watching.